Well, hello and welcome YouTube, Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Alright, step one inside here. Now, if you've been with me for the past couple videos that I've had, we've been working with polynomials, specifically factoring them, solving them with some roots, whether they are rational, irrational, imaginary, any form of complex numbers or anything like that, using division, like I said, factoring, a lot of factoring methods, going back to some of the other things that we did with expanding binomials. We're going to start with a lot of those, and Pascal's triangle may be used here and there, a lot of things. I got an overview of those problems to look at right now, and thing I've been given, guys, 50 questions long. Now, I don't plan on making this thing super long as is. They are sectioned in some sort of way where you can figure out what they're like. So, once I do one kind of question, probably going to speed through that other one. Just say, here's what it is. If you wanted to try it for yourself, pause beforehand. But here's what I'm going to get. Maybe caution of this and that, depending on the problem. But we'll go to work on it. Now, if you remember, I do mental factorization. Okay, and with quadratic formula, if I use that, I do the discriminant first. I'll use synthetic division when I feel I most should. I'll warn about maybe when not to and why. But otherwise, let's get straight into it, guys. Fantasy football draft on the line coming up in a timely manner, so we got to keep going. All right, so numbers 1 and 2, we're going to simplify these expressions here, and in doing so, we're going to combine like terms. Now, you see 3 different polynomial quantities, and by the way, we want to get these in standard form in the end. I see this looks standard form-esque, these do not. So I want to make sure that when I combine everything, standard form. It would be a nice rewrite, a nice way to rewrite all these things right here, just straight up, in not having parentheses. So the negative distributes into these 3 guys right here, which changes their sign. I'm going to get a minus 5 plus 5v squared plus 7v to the 4th. And then another distribution of the negative right here, minus 2v squared plus 3v cubed plus 7v to the 4th, like that. I kind of fizzle out at the end on the last 2. Plus 7v to the 4th. All right, we'll start with my v to the 4th. So it looks like that's our highest degree. We got 3v to the 4th plus 7v to the 4th is 10v to the 4th plus 7v to the 4th is 17v to the 4th power. And then the cubes, 8v cubed, I think plus 3v cubed. I think that's it. So we get 11v cubed there. Let's cross out some things along the way here. Squareds, 5v squared minus 2v squared is 3v squared. You can see it's a little easier to see things from that. And then we got v's and constants. Negative 3v, I think that's it, and minus 5, I think that's it. Let's double check that. Minus 5, boom, boom, boom. Yep, we got them all taken care of, and that is a quartic 5-term polynomial right there in standard form. They don't say that, but you know what? It's kind of an assumed thing that you do for a lot of the things that you have. By the way, I didn't mention this, and I'm not using it here, but you might want to have a calculator ready for some of the future problems that we're going to have, depending on, especially if we're doing the rational root theorem stuff. Just kind of be ready for a possible calculator. Okay, number 2 right here, subtraction of these guys, but addition of these guys. These signs don't change, but I think the rewrite's going to help with the subtraction. I see in the background of my screen there's that AM PM guy, and that kind of freaks me out. I didn't know what was behind me. Minus 4p to the minus 4p minus 4. So subtract p cubed and 4p and 4, and we just add these straight up. So again, a rewrite without parentheses. Adding the negative is a minus, and adding the negative is a minus there. So kind of nice to have that. I see p cubed as the largest thing here. So negative 7 minus 1 plus 1. So that's going to be negative 7p cubed. Then I have p squareds, none of which I see. We're going to p's. 4p minus 4p is 0. Minus p is negative p. And then, be sure, I kind of like crossing out right here. I see a 7 minus 7, which is 0. Minus 4 is negative 4. So in standard form, you have a cubic trinomial there. Negative 7p cubed minus p minus 4. It's a very, very negative set right there. Okay, numbers looks like 3 through 8, we are going to find each product. And that does mean simplify as well. And I don't know, honestly, I almost want to skip these and go to these next. But it's, I think these look like special cases. So maybe that's why they have them. We've trinomials times trinomials. In one of the problems, how about I'll go ahead and just go straight up in the kind of multiplication facet of distribution, boom, boom, boom. The other one, I'll go ahead and draw out a box for you and say, okay, here's what we can do. But I don't want to draw so many arrows as to confuse you. So let's start with the first 3. 7n squared will multiply with 7n squared, 3n, and negative 1. And we're going to get 49 n to the 4th. And that's not from 2 times 2. That's from 2 plus 2. N squared times n squared is n to the 4th from 2 plus 2. Because n squared times n isn't just 2 times 1 being 2, it's 2 plus 1. So plus 21n cubed, and then 7n squared minus 1 is negative 7n squared. Let me also bring this to light as well. None of these terms should combine here. If these three did not combine, multiplying them by something else should not combine them later. So if someone accidentally writes a squared, well, I don't want these to combine, as they never should have in the first place, so be ready for that. Instead of writing in a row, I'm going to write things underneath that'll kind of line up, and what's nice is these are in standard form. So when I do the next three here, I'm going to multiply negative 8n by 7n squared, 3n and negative 1, so these go down 1 degree. I'm going to line this right up under the n cubed, negative 56n cubed it looks like. And then, remember it's a negative multiplying. This is one reason why maybe you want to use the other method. People sometimes forget the negative here. Negative 8n times 3n is negative 24n squared. And then negative 8n times negative 1 is positive 8n. So those signs should also change alongside what we saw there. And then lastly, the 6 will multiply by these. And then, like I said, I want to line up like terms here. 6 times 7n squared is 42n squared there. You don't have to do this. I'm using it for space. But it's not a bad practice right here. 6 times negative 1 is negative 6. So when I add things up, things are already alike as far as lining up. There is no other n to the fourth right here. So I'm going to write right underneath that 49n to the fourth, and this is standard form. So 49n to the fourth there. 21n cubed minus 56n cubed is, negative 35n cubed. Oh, no, I'm sorry. Yeah, no, I'm not sorry. Yes, that's right? Then negative 7 minus 24 is negative 31, plus 42 is 11. I sure hope I'm doing this right. I should get the calculator out for that. Plus 26n minus 6. Standard form, another quartic, 5-term polynomial for us. Okay, and let's do the same thing here, only this time I'm going to go ahead and draw that box, differentiate it a little bit based on what some people may or may not do. That is a very small box. Let me just draw my own. A little more rectangular, how about, because I think these answers may be longer than taller. So I'm going to draw myself a 3 by 3 right here where I line up, say, the column with these three terms here. Let's get an m squared, 6m, and negative 3. And then here we can get 5m squared, 5m, and 4. And by the way, if this was factorable, I'm not trying to factor after. Simplification means no parentheses. Get it all spelled out. Same thing here in case something can factor, just leave it. So we multiply here. Pretend like these are the areas of each individual little rectangle, this by this. 5m squared times m squared is 5m to the fourth. 5m times m squared, or m squared times 5m is 5m cubed. And m squared times 4 is 4m squared. Then 6m times 5m squared, we get 30. It's probably easier if I don't say anything for a moment here when I multiply. Just what I'm going to bring up here is on this next one, this is one of those benefits of using the box, like I said. Because it says negative 3, I think you're more inclined to remember to make it a negative 3 when we do this here. So that's going to be negative 15m squared, and then negative 15m, and then negative 12 for those. Now, the end result is adding up all these gets you the area of that rectangle. Yeah, we got to add all these things up afterwards. So find things that do line up. You know what? This was a cubed. You can see that when I was talking, I messed that thing up. So there you go. See? You got to make sure you're checking on these. Something that lines up kind of nicely with these, though, as well, as you can see that these two like terms combine, these three like terms combine right here. This only kind of really happens if you have things multiplying in such a way they're in descending order of degree. They line up their degrees, things like that. So you see what combines there. Like I said, not always this pretty, but this one is. So 5m to the fourth is my leading term there, not combining. These are positive, so that's 35m cubed. Same thing there. 4 plus 30 minus 15 is 19, so 19m squared plus 9m and minus 12. Another quartic 5-term polynomial for us. Okay, these next ones right here, what you're seeing, or the next 4 are all special cases. They're not as simple as FOIL when you distribute first outside, inside, last, and do what we did before. You can. I'm probably going to do it for the first one just to kind of give you that grasp again. Multiply 8b by 8b and 3, and negative 3 by 8b and 3, and you get 64b squared plus 24b minus 24b minus 9. You see the middle terms cancel and you're left with 64 squared minus 9. This was a special case because those middle terms will cancel each time that you have these conjugate pairs of a plus b or a minus b times a plus b. That is a difference of two squares. in the difference of two squares format, a minus b times a plus b equals a squared minus b squared. So what I could have done instead was said, and I'll do it on the next one, I square 8b, square the 8, square the b, get 64b squared, minus square the 3, you get 9. And, look, this wasn't much slower right here, necessarily. I think it does help when factoring, especially because your goal in factoring is, there's no middle term and you're trying to add to it, so that can help. But it's okay to do here as well. And let's do it right here this time. This is another difference of two squares, a plus b, a minus b. And that equals a squared minus b squared. Now, I'll be honest, I don't tend to write this middle step right here. I just go straight into it. You square 14x, you get 16x squared. You square 7, you get 49. And that's your result. And by the way, these are still standard form. If for some reason the constant was written first, I would have rewritten it to have it there. 7 and 8 are in that same vein. They are special cases. And these ones are... for me, it's a little better to kind of know these because of what they represent with completing the square, how you don't want to mess it up, and things like that. Let's do the conventional way first, though. Squaring something does not mean, hold please, does not mean squaring this guy and then squaring this guy or whatever, right? It's not a difference of two squares. You don't distribute the square into that. Squaring something means multiplying something to itself. And when it's an addition or subtraction, two different terms in there, you got to make sure that you recognize what would happen is the same thing as we would do in polynomial distribution, foiling. Every term multiplies with something in the other quantity. So in this case here, that would become 4x squared minus, I'm doing this, boom, 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 minus 16x, and then another minus 16x here, and then plus 64. So that becomes 4x squared minus 32x plus 64. Now, that's one way of doing it, and recognizing you're supposed to do that. Alternatively, of course, this is what is known as a perfect square trinomial coming from, this was an a minus b right here. And what happened, if you notice, was the first term did get squared, the last term did get squared, and they were added. Excuse me, because squaring a real number gets you a positive result, so that will be a plus right there, despite the fact there's a negative 8. But the middle two terms, as you notice, it's the same thing twice. And that's because it was 2x times negative 8 and negative 8 times 2x. That's the same thing, literally, twice right there. So adding up is doubling up that product. That's doubling up 2x times 8, or 2x times 8. And then I subtracted because the 8 was negative. So that happens there, and if you added them, then it would be a plus 2ab like that. So I will use that concept for this one right here, and you got to be careful with these bits here. Like I said, this intermediate step I don't tend to do. But what we're first going to do is square 6n, and then, subtract, doubling the product of 6n squared and 8. Maybe it's worth you guys writing in this case. And then adding 8 squared right here. So 6n squared is 36n to the 4th. And then doubling 48n squared, so that's negative 96n squared, and plus 64. And beyond anything else here, what you do get a look at before we start factoring these kinds, the cortex in quadratic form, is you notice where this comes from. A couple n squareds multiplying themselves out. So we'll make sure to factor those down the line. But that's that right there. All right, expand completely, numbers 9 and 10. I may need some room for this, and especially to write out or draw out Pascal's triangle. This may assist me. I happen to know it for rows 3 and 4, but that's all right. Now, Pascal's triangle is a triangle where for each consecutive row, you are adding a new value, and that value is the sum of the two values above it. 1 plus 2 is 3, 2 plus 1 is 3. It is symmetrical. 1 plus 3 is 4, 3 plus 3 is 6, and on the other side, you get 4 and 1. Right now, I'm going to go to 5 rows. Just 4 rows is needed, and I will keep adding on to this as we go if I do. I can't imagine we'll do anything more than 6 or 7 rows. And by the way, I called that row 4, even though that's 5 rows. Right? So the top row is actually row 0. Row 0, and then row 1, and row 2, and 3, and 4. And, this number applies to the degree of the polynomial here, because when you cube something and all like terms fuse in how they're supposed to, you actually get 4 terms out. And what we found in Pascal's triangle right here, these are coefficients that multiply by your terms. I don't know if it's in me to write out the full formula here. I might kind of have to and get the idea. When you have a plus b to the n power, you're using Pascal's triangle. So, I'm actually going to leave that little part out. But in your first term here, you take that, like here. I I don't want to talk about certain things here, but your first term, a gets raised to the nth power and b gets raised to the 0 power, and it multiplies by your coefficient. And then plus a gets raised to 1 less power, while b gets raised to the first power, and then it's times the other coefficient. Plus a gets raised to 1 less power, b gets raised to the second power, the next coefficient, times the next coefficient, and it keeps going. So that's what we're going to do here. Let's write this first one out, and this is where you might need to use a calculator as well, actually, for binomial expansion. So 4y squared plus 2x quantity cubed, what's going to happen is we're going to look at row 3, and we're going to have 4 terms. We're going to multiply this first set by 1, this first coefficient here. 1 will multiply 4y squared, and 4y squared will be cubed. 2x will be to the 0 power. And you can see these will all be degree 3. 3 plus 0 is 3. Plus, go to the next coefficient, 3. 3 multiplies by the first term here, 4y squared, which will get squared. And then 2x will be raised to the first power. 2 plus 1 is 3. And then there's that 3 right there. Plus, next 3 times 4y squared gets raised to the first power. And 2x gets squared. And then plus 1 times 4y squared gets to the 0 power. And 2x gets cubed. Now, when I do this next time, you're going to see me take out some things. For example, when you multiply by 1, it has no effect. When you raise something to the 0 power, it has no effect. When you raise something to the first power, it turns into 1. When you raise something to the first power, it has no effect. You'll just have 2x. So you'll see me leave these ones out next time, probably. And for me, I should leave them out right now. I'm kind of omitting those when I say the rest of it. I got to do 4y squared cubed. 4 cubed is 64. Y squared cubed is y to the 6th power. You do multiply those. Now, before you do 3 times 4, make sure you are doing 4 squared and multiply that, and the 2, by the way. 4 squared is 16, times 3 is 48, times 2 is 96. So 96. Y squared then gets to the 4th power right there. Squared is to the 4th power. And then x right there. Now, what you generally see me do is write these alphabetically in that... I would generally write xy to the 4th power, but given, my idea of standard form, and I might rewrite this a little bit, but my idea of standard form is generally treat the alphabetically first letters as the most dominant ones, but it looks like y seems to be our dominant force here, and I'm going to go ahead and leave it as such because this is a 6-degree polynomial, so I'm going to go ahead and leave these alphabetically in reverse just for the sake of it, and I think I'll do it for the next one as well. You know what, I assume an answer key will probably say that. I'll just do it for those. So unless my students have a fit with, wait, why is an x first? I think y is being treated alphabetically first in the problem. Let's just do it. 3 times 4 times 4, 2 squared, right? So 12 times 4 is 48. And then y squared here, and then x squared there. As you can tell, I'm a little chatty. And then 2 cubed x cubed, that's 8 x cubed. And you know what? I do want to make sure that I'm kind of in standard form here, and I am. This is degree 6, degree 5, 4 plus 1, degree 4, 2 plus 2, and degree 3. 6, 5, 4, 3, and we're all good. So that's the binomial expansion of that guy. Let me move myself to kind of spill out this other one on the bottom, if you will, if that's okay. Let's do y plus 2x to the 4th power. Do you mind if I switch it? I'm a little OCD on this one right here. Even this one has the larger thing. Let's go and write that as 2x plus y to the 4th power. They're both even degree right now, or equal degree, I should say. And that's a larger coefficient. I like that more. It doesn't matter. But anyway, we are going to expand this thing, which means we're going to refer to degree 4 this time. Row 4. 5 terms will be spelled out here. The first term will be multiplied by 1, second one multiplied by 4, and by 6, and 4, and 1, alongside whatever gets manufactured here. 2 is going to be raised to some powers, and then we got to multiply them by these numbers here. So these coefficients aren't just what show up in the end, right? They get multiplied by whatever's inside here. So in the first one, and I said I would kind of expedite this a little bit here. 1 I don't have to write, but 2x will be to the 4th power, and y will be to the 0 power. Plus, then 4 times 2x gets cubed, whereas y just gets raised to the 1st power. I'm just going to leave it like that. Plus 6. Oh my goodness. Color in the lines, Mr. Robinson. 2x gets squared. Y gets squared. I'll write y squared. That's good. Parentheses. Plus 4. And then 2x is to the 1st power. And then y gets cubed. And then plus 1 times 2x to the 0 plus y to the 4th, like that. So as we now kind of get all that full expansion, 2 to the 4th is 16. So it's 16x to the 4th there. Plus, and then 2 gets cubed, that's 8, times 4 is 32. 32x cubed y. Plus, 2 squared is 4, times 6 is 24. It's 24x squared y squared. Plus, 4 times 2 is 8, so 8xy cubed plus y to the 4th. Now, all of these are degree 4, but I would argue this is in standard form, assuming I'm treating x as my dominant variable, because x is alphabetically first there. So as the x's go down, when there's a tie to the degree, go to the alphabetical, or your dominant variable, and that's what mine was in this case. All right, there's the expansion of that guy, and that's it there. Let's keep going. Okay, now these ones here, okay, I do have to copy over. See, I didn't preview these beforehand. Give me 1 second. I'm gonna redraw Pascal's triangle, just show it's not that hard. I just don't have much room, so I guess it's worth me redoing anyway. I need a few more rows here to the 5th. Looks like the most I need is to the 5th power, so I just need one more row. 1, 4, 6, 4, 1. You know, you do this a couple times, you'll remember what some of those are. Not memorize, but you'll go like, I've seen that before. So you'll probably kind of know when you messed up if you do. That's good. That's row 5 right there. They ask for the 5th term in the expansion here of x minus 2 to the 5th power. Now, this can come with some things to be careful with, specifically the sign, but as long as I guess we treat negative 2 to the specific power, you're pretty good here. Now, the expansion to the 5th power, this means we don't have to write out all of them, but you do have to know what it looks like to get to that term. The 5th term, here's the first term, 2nd term, 3rd term, 4th term, 5th term. The 5th term does get multiplied by 5. Right? And then if you recall, the first term gets raised to the 5, 4, 3, 2 first power right there, second to last. And then the second term here gets raised to the 0, 1, 2, 3, 4 power right there. So this will be where we get our 5th term from right there, okay? Remember, 1 plus 4 should be 5 in case you mess something up. In case you count 1, 2, 3, 4, 5. This shouldn't be to the 5th because 1 plus 5 would then be 6. Negative 2 to the 4th is still a positive 16, and then times 5 is 80. So you get 80x, 80x. That's that term there. Now, if this was this term or this term or this term, negative 2 would have been raised to an odd power, and raising to an odd power would have meant that it would have been a negative number there. This one was not the case. All right, the third term in the expansion raised to the 5th power of this guy. So the third term would be 1, 2, 3 right there, and that's a 10. So we're going to go ahead and take 10 and multiply by 2b cubed, which will be raised to the 5, 4 third power, and then times 1. Wait, listen, this is going to have no effect, right? But 1 would be raised to the 0, 1, 2 power. 1 squared is 1, times that, no change. 2 cubed is 8. 8 times 10 is 80. Another 80 there. And then b cubed to the 3rd power is b to the 9th, not to the 27th. You do multiply those. If I didn't mess anything up right there, that should be the 3rd term in the expansion right there. That's all that's being asked. All right, find the coefficient of b cubed a in the expansion of this right here. What I assume they mean is, and it's not just this number, remember, you have to make sure to see what this thing would look like. So b cubed a, I think all I want to do is crack down what term is this in. What term is this in? And we're assuming that this is the dominant variable here, meaning it first starts 4th, it starts the 4th, then 3rd, 2nd, 1st, 0 power. So in this one right here, when you look at b cubed a, in row 4, this is b to the 4th, a to the 0, and this here is b cubed a to the 1st. It's your second term. So your second term right here gives you a coefficient of 4. And I don't know if they just mean the 4 or if they mean, because what happens here? This b gets to the, and all they want is the coefficient, but the b gets to the 3rd power, right? And then the 3a gets to the 1st power. We know this because b cubed a. But that does have a 3 in it. So the answer is either 4. I don't really know. That's the starting point. I'm going to assume that's not it. Or 3 times 4, which is 12, right? The 3 to the 1st times 4. The other variable portions don't matter. We know what it is, and they just want the coefficient. I'm going to assume they want that part there, and that's just a portion of what happens in the end. Yes, these are factors that multiply by our ultimate coefficient, thing to make our ultimate coefficient, but not fully. All right, coefficient of x to the 9th. Ooh, I see this. Of x to the 9th. In this guy right here. So when it comes to expansion, x to the 9th is, notice how this was x cubed? That's going to mean x cubed cubed, right? So whenever we get this one getting cubed and this to the first power, since it's all to the fourth, we are back in row 4, and it looks like the cubed here, first power, is once again this guy right here. So we are going to be using that 4 for this. This will be the second term. So it'll be 4 times, right, x cubed times, here's the important guy, 4 to the first. 4 to the first is 4 times 4 is 16. And I do think that's what we're looking for right there. We know it's the term is x to the 9th, 16x to the 9th, but that is it. All right, and that seems to be the end on binomial expansion tactics. Let's go ahead and divide. Now, when you have a linear division right here, it is possible for you to use synthetic division. I'm going to not use synthetic division on this problem, and actually on this problem either, and I'll tell you why later. I'm actually going to use long division, and you know what? If for any reason we get to diversify some of our work, we can use some long division, some synthetic division. Now, if you haven't seen me do long division before, not if you haven't seen it, if you haven't seen me do it before, my visual style might be a little different than yours. Make sure you have your own way of writing it out. I will say out loud what I do, but just be very cautious when it comes to that. So, hey, all of this here, I got to rewrite it. I don't really have much room. This is very little space for these guys. 9, let's write it out here. 9r to the 5th plus 80. This is one of those times where I can totally pause the video and come back. But I think installing for time, as long as I can write and talk at the same time, I want to mention why I'm not going to use synthetic division. I'm not going to use synthetic, and it's not that you can't, but I'm not going to use synthetic division here because when I divide this, I will not be dividing by 9r minus 7. I'll be dividing by r minus 7/9 right here, which means I got to work the fraction. It's not a big deal, but I'd be working with this fraction here, and then ultimately, I'd still have to divide by 9 afterwards. Not the biggest thing in the world, but people tend to forget that aspect of it, that this is truly what you're dividing. Excuse me, and 7/9 is your root. 7/9 is your root on that, right? But you're dividing by r by minus 7/9, and then you got to make everything 9 times smaller after that. People tend to forget those notions. They just assume that 7 is your root and you move forward. That's not true. By the way, on these, I know that this is from our CUDA software and program stuff. I have no expectation that these will not have a remainder. I expect that all of these, if not whatever, will have a remainder that is not, will have a remainder that's not 0. So if you don't get a remainder of 0, don't be too hurt by it. That's the nature of it. And you know what? That's another thing. Synthetic division, when you're trying to feel out that remainder aspect, dividing that part by 9, I wouldn't. I wouldn't until I hit something like this where it's a 1, x to the first power, something like that. So we'll do that later. Anyway, let's proceed. We got to figure out how much this leading term goes into that leading term there. How many times, multiply it out, subtract the result. 9r goes into 9r to the 5th, 1r to the 4th times, as in 9r times 9r to the 4th is indeed 9r to the 5th. Negative 7 times r to the 4th is negative 7r to the 4th, and we will subtract this result where these guys go away, go bye-bye, and then these guys subtract. Now I'm going to subtract the negative. Here's something I don't do. Some people tend to change the signs and then do that. I don't. I don't know why. I don't. In my head, I do know I'm subtracting a negative, excuse me, which does become addition. That is 90r to the 4th. Bet you thought I was going to say r to the 8th, didn't you? 90r to the 4th. Bring these down because they are subtracting with a 0. Now, this is longer, right? Long division is in the name. It is longer than the other guy, but I think less things will get hurt along the way. 9r goes into 90r to the 4th, 10r cubed times, multiply those. You should get 90r to the 4th to cancel outright, which we will. And this is negative 70r cubed. Subtract that result. And listen, there are times where you have to use long division, and synthetic's just not an option when it's not a linear factor at all, and you can't factor it, and you don't want to do it twice. You'd have to do this anyway. Subtract the negative, you are going to get positive 9r cubed right there. Now I imagine, until we get to the last term, we have no expectation that these things will not go into 9r an even amount of times. I don't think we're going to get fraction coefficients here. 9r gets into 9r cubed, r squared times. Multiply that out, you get 9r cubed. Negative 7 times r squared is negative 7r squared. Plus, whoops, not anything, not plus anything, got to subtract. Subtract that result. Subtract the negative, becomes addition, it becomes negative 72r squared. Then plus 11r plus 39. So like I said, I needed this room here. And here's another thing I do visually. If you noticed, I bring this thing down again to say, hey, I need this part right here, right? 9r goes into negative 72r squared, negative 8r times. Multiply that, we get negative 72r squared. Multiply the negative by negative here, we get plus 56r. Keep in mind we will be subtracting these right here. I might be interfering here. Subtract these, they're gone. And then subtract these here, it looks like we're getting negative 45r. And then 9r goes to negative 45r negative 5 times. So minus 5 right there. So that's negative 45r. And yeah, this thing's not going to be clean. Negative 7 times negative 5 is plus 35. And subtract that result here. My remainder is going to be 4. Now this 4, being the remainder, 9r cannot go into 4. As long as this has a higher degree than that, it can't go into it any number of times, which means 4 will divide by that whole still. 4 is my remainder that will, well, remain. So the quotient of this is this guy up here, r to the 4th plus 10r cubed plus r squared minus 8r minus 5. And the remaining portion of the quotient is that plus 4, which never got to divide by 9r minus 7. It's that much out of the whole. It's like if it's remainder 1 after dividing by 2, there's still a half left after that, right? Plus 1/2. And that's what's going on there. Now, with my students, we practiced factoring these things after. I can't imagine that's easy factoring. Plus, we have this right here. We'll leave it, right? We want the quotient. That is the quotient. We'll use division later to get factors when we talk about rational root theorem. That'll be fine. And again, I'm going to avoid synthetic division at least one more time here. There might be other times where we do some long, do some not long. But you know what? It is long. It takes a little bit. And, you know, it's a great way to stay in shape on these problems, I'd say. And it also might be worth it for me to write a little smaller or give myself more room. I don't know where you need the room. Because these have remainders again, I'm not inclined to want to really use synthetic division. I'm a little hesitant to really speak on it. Don't want to mess you up. Rather practice some long because, hey, you need to know long. Synthetic's nice. I like it. When I should use it. Am I done stalling and talking? Good. Let's go. 9r goes 9r to the 5th. Not 9. R to the 4th times right here. Kind of like last time. 9r to the 5th. 6 times r to the 4th is 6r to the 4th. Subtract. You get the deal. You know, these are 50 questions. We're on 16 right here. Sure hope I can make my draft. Subtract that result, negative 7r to the 4th right there, minus 93r cubed. I'll tell you what, if my draft interferes, I'm pausing the video. You won't know. I'm pausing the video, I'm doing the draft, and I'm coming back to these. I don't even know what pick I have here. All right, 9r plus 6. Oh, that already doesn't go in. See, I said 72, but I didn't write it. Minus 72r to the 4th. 9r goes into 72r to the 4th, 8r cubed times, I guess I'm sticking with this color, 8r cubed times, so that's 72r to the 4th. Remember, I'm multiplying these. 6 times 8r cubed is 48r cubed. Subtract, bye-bye. Subtract these two, I get negative, 141. I guess that goes into 9. I don't know. No? What did I do there? 48. Negative 141 r cubed 72. I don't think 9 goes into that number there. Hold, please. Let me just make sure everything's going right. Okay, I got it. My issue was this should have been negative right here. Subtract, and that's negative. And that means we're going to multiply by a negative right here. That does change everything there because now this is minus. And now we're going to subtract the negative. So let's take a look after that. That's going to be adding that, and that is, I still don't know, 45, negative 45. You know, I've never really made a mistake on those before, but I did address it. And it was plain as day, right? 9 can't go into my number, so I'm going to assume something kind of went wrong there, and I addressed it. I think I was talking over it, and not going to do it again. With a different subject, that is. I will keep talking. 9r goes to negative 45r cubed, negative 5r squared times. So that's negative 45r cubed, and then minus 30r squared. There's a lot of pressure in getting these things right if I want to make a solution guide video. I don't want to mess you up. So minus the negative is plus. That will be plus 9r squared. Kind of running out of room, or very much running out of room. You'll see me shift this over, I suppose. I don't know how. 9r plus 6. 9r goes into 9r squared, r times. So here we go. Just write it over here. 9r squared plus 51r plus 26 minus 9r squared. 6 times r is 6r. And there you get 45r. 9r goes into 45r 5 times. 45r, 6 times 5 is 30. Subtract that, we'll get negative 4 this time, and that's our remainder here. So the quotient on this guy now, this time, is this guy, and then with this remainder divided by 9r plus 6. So it's r to the 4th minus 8r cubed minus 5r squared plus r plus 5, remainder of negative 4 over the quantity 9r plus 6, right there. So if all went right, and I think it did there, at least till the end, that's what we get. These next ones, guys, I'm going to speed things up. I got synthetic division now with a 1x right here. That meets my root. You know, it's x equals 9. The 9 is used in the synthetic division on this guy, and I'm going to go ahead and do that. And let's diversify. Let's use some green. Let's use some green right here. All right, let's lighter green. 9 is the root here. Everyone kind of draws this diagram differently, but it's all the same result. You're going to go down in degree with the coefficients. I got the 5th power, 4th power, 3rd power, 2nd power, 1st power, and constant. And if one is ever missing, you got to place a 0 in there. All right. 9 times 9 is 81. Add that, you get 10. If you don't know synthetic division, I'm adding the result. I'm not going to explain why it is. I have other videos on that. But I'm going to add the results of these numbers here, and with not anything here for reasons. I'm going to multiply these numbers down here by this number and write that up there. So 9 times 10 is 90. Add that, you get 4. 9 times that is 36. Add that, you get negative 3. And I'm going to go fast. 9 times 9 is negative 27. Add that, you get 5. Times that is 45. Add that, you get negative 2. Now the last guy is the remainder. And then this is the constant, linear, quadratic, cubic, quartic right here. This goes from an x to the 5th power to x to the 4th power. So the quotient here is 9x to the 4th plus 10x cubed plus 4x squared minus 3x plus 5. With the remainder of 2, it's minus 2 over x minus 9. And, you know, one more time, you go, Mr. Robinson, this was a lot faster than the last one. Well, the last one had issues with fractions. I could do one with fractions. I don't know. I'll decide later if I kind of want to. But, you know, I'm not going to there. And suddenly I might not do it again. You want to see one with a fraction? Let's do it with a fraction. Let's check it out. Maybe you prefer it more. My root here is, remember, you set this equal to 0. You add 2. And you divide by 6. You get 2/6 or 1/3. 1/3 is your root. That means to start with here, I'm not dividing. And listen, this might be faster for you because 1/3 is not that bad. 7/9, maybe for people it is. 1/3 means divide by 3. So that should be pretty clean here. So we're actually not going to divide yet by 6r minus 2. We're going to start by dividing by r minus 1/3, that factor. Then, and this is all multiplied by 6, I'm going to divide everything by 6 after. Not too bad. Just got to treat the remainder right. And I'll admit, sometimes I don't think I treat that remainder right either. So I got to be very conscious of it. Got to make sure I'm not messing that part up. The remainder, I guess, will also be 6 times larger, I suppose. See, that's the thing I'm gonna second guess myself with here. So anyway, check this out. This is not in standard form. Ooh, this is not in standard form. Be careful. We have an r to the 5th first to deal with. That's the 6 that goes first. And then r to the 4th. And then r cubed. Remember, synthetic division knows nothing. You can't just write these numbers like this. Synthetic division knows nothing about the variables when we write them out. We have to give them everything that it's, we have to make it assume right. So 14, negative 62. It's like a traffic light doesn't know whether a kid is driving without a license or not. Blah, blah, blah. I don't know what I'm saying. Okay, synthetic division. Bring down that 6, multiply by 1/3. Divide by 3. Divide by 3. You get 2. Subtract that, negative 48. Divided by 3 is negative 16. Add 30. Divided by 3 is 10. Add that is 24. Divided by 3 is 8. Add that. Divided by 3 is negative 18. Add that is 5. So again, not too bad there. If it was 7/9, you got to divide by 9 and multiply by 7. 2 things in the works. Still probably faster than long division. But don't forget, we're not done with this thing. This is now, this whole thing that we didn't yet divide by 6. So now this is 6r, this is to the 4th power now, minus 48r cubed. I mean, you could divide by 6 right now if you wanted to. But it's this thing that I got to think about even how this remainder works suddenly. I'm kind of a little iffy on it. I'm going to double, triple check on what that should look like. Maybe it's 6 times larger on top and bottom. So actually, I have to think about that for a second. I often don't use synthetic division for these. Plus 30r squared plus 24r minus 54 plus 5 all over r minus 1/3. And all of this is being divided by 6. So, you know what? The remainder I think is going to be the same because dividing all this by 6 is also multiplying by 1/6. And then when this gets multiplied by 6 here, I guess 5 is still the remainder. I am going to double check that when it comes to the actual. There must be an answer key somewhere for this. I can even photomath it. But just to be sure there, dividing everything by 6 will get us into r to the 4th minus 8r cubed plus 5r squared plus 4r minus 9. And then I guess plus 5 over 6r minus 2. I guess so. I'm going to pause and double, triple check that right there. See that all's good, and then I'll come right back. You won't even know that I'm gone. All right, I'm back, and you know what? Answer's looking good. It is a remainder of 5. So dividing by 6 is multiplying by 1/6. That means that 6 multiplies by that quantity there, which gets us back to 6r minus 2. I'm not going to say I take back that synthetic division was preferred. I'd say that I would generally do synthetic division more, but I can see where people might botch some mistakes when it comes to it. You really do just have to be careful regardless of what happens. Remember what your root is and what goes on, how the fraction works. That's all for division. I don't have fractions the rest of the way, so I will use synthetic division, and I save myself a little bit as time and room. So synthetic division the rest of the way, guys. Just be very cautious of your signs here. It looks like they're kind of doing the same thing. These all seem to have remainders. No worry. The root here is -8. We tend to be using synthetic division more, but you know what? Long division sometimes has to be used. I don't know if these are any of those cases. I saw some maybe preferred cases, and you got exposure. All right, I'm going to go fast here. Times -8, add, times -8, add, times -8, add, etc., etc., etc. So how fast can you go with that? Well, it depends. Anyway, so that guy there, that is the remainder. So the quotient goes from quintic to quartic. This is n to the 4th minus 5n cubed minus 4n squared plus 10n minus 3 minus 1 all over n plus 8. That is our remainder there. Yeah, I'm going to kind of go fast the rest of the way. Got another -8 root on number 20. -8 root there. Let's line these up. They're in standard form. 1, 15, x to the 4th, and then 51x cubed, 49x squared. New 69 plus 23. Ooh, not much room. 1, -8, 7, -56, -5, 40, -9, 72, 3, -24, -1. At least the remainders seem to be close number-wise. I'm not getting a 564, which is very possible because 564 is still, x can't go into 564 any number of times anyway. So from x to the 5th to x to the 4th, x to the 4th plus 7x cubed. At this point, I'm building more of an answer key than a solution guide. Done a couple of these now. Looking pretty good. -1 all over x plus 8. All right. One more. This does not look standard form again, so please be careful on that. Oh, 2 more. I'm sorry. But this one does not look standard form. Just some good practice. Largest term is to the 5th, as has been. The root is +4 here, as we will add. 8, and then to the 4th is -22. Cubed is -42. Squared is 17. First power is -44. Constant is 31. And you have to go down to the constant. If constant's missing, you got to place 0, just like any other missing things. 8, 32, 10, 40, -2, -8, 9, 72. Oh, sorry, not 72. I was multiplying by 8. 36, -8, and -32. Very close again, -1. So there's our remainder there. So here we go. This is 8k to the 4th plus 10k cubed. Yeah, I didn't want to do long division on all these. Thank goodness. Definitely like my synthetic division, y'all. All right, last one on division, number 22. Let's use Geen. In standard form, indeed. Now, listen, I just want to mention, if this term was missing, we would put a 0 in place on that thing. We didn't run into any of those, so I just wanted to be very, make sure you know that. Root is -2 here. We got 6, 20, 12, -17, -9, 25. All right. Did I do that right? 9, I think so. Sometimes I'm forgetting what I'm multiplying by. I just want to kind of confirm that. Looking good. All right, it's remainder 7. Little large remainder. we get 6r. 6r to the fourth plus 8r cubed. Minus 4 squared minus 9r plus 9. With the remainder of 7 all over dat r plus 2. You know, what I was working with my students a bunch of times was, hey, practice. When you practice division, we'll get a remainder of 0 to know that you're doing it right. But here there are remainders, and you know what? You might have remainder 0, you might not. So there it is. All right, factoring. This is something where I could go extremely fast in some cases, and I kind of will in some cases as well. Factoring, we're not solving anything, just factoring straight up here. So there's x is the greatest common factor, and as this is a 1x squared right here, we got to find two numbers that multiply to -8 and add to -2, which is -4 and +2. And look, I'm done with the problem. I'm not writing more than that right there. Okay, I might even write the f of x. I'll just write equals if that's cool. Another common factor of x here, and then you're left with x squared minus 9. So, hey, you know, this isn't factored completely yet. This is a difference of two squares, like I mentioned before. You got to recognize that 9's a perfect square, and clearly we're squaring, it's a quadratic. This is a 1x squared there. So we're squaring x and we're squaring 3. That makes x minus 3 times x plus 3 factor there with the x common factor. Okay, so some will go kind of fast in that regard here. This one has no common factor. We can look to factor by grouping here, which should seem to pan out. So factor by grouping, find the greatest common factor of the first two, which is x squared. You're left with x plus 3. And you factor a 3 out of the next guy, and you're left with x plus 3. X plus 3 is a match, or it's identical factors in both of these guys. Factor out x plus 3. And here you're left with x squared plus 3 in the other guy, x squared plus 3 like that. And that is our final result. Again, I'll go as fast as kind of needed for these ones. I don't want to linger. Another factor by grouping appearance here. This is factor out an x squared again. You get x minus 5. And if you factor out the right thing here, we should get x minus 5 again, which is not just the negative, but a -1. And I want to stress that because, you know, people tend to forget that -1 when you factor everything out right here. When you factor out x minus 5 here, the other guy is x squared minus 1, not just x squared, and you sure don't multiply them to get -x squared. And I won't box yet because I have, once again, a difference of two squares. X squared minus 1 is x minus 1 times x plus 1. And then times x minus 5 right there. I don't know. I want to check the future and see. We're not getting big factors here, guys. We're not getting the ones with a 2 and a 7 and whatever. And I think those are worth practicing here and there. Doesn't seem to be happening in the case. This is a quadratic. This is an octic in quadratic form. These go down even degrees from 8 to 4 to 0. So we can treat it like a quadratic. We can either use that u substitution and instead say f of u is u squared minus 2u plus 1 and factor that way. I'll start with that. This is a perfect square trinomial here where it's u minus 1 quantity squared, right? -1 times -1, -1 plus -1. And then we substitute x to the fourth back in. That's kind of, u took place of x to the fourth as u squared is x to the fourth squared. So this would then become x to the fourth minus 1 like that. Now, I'm not going to use u substitution in the future. We'll recognize, if we have these again, we'll recognize what it is that is being quadratic-like, and we'll just deal with that if that's okay. Now, we're not done here yet still for several reasons. You know, being squared means multiplying something to itself there. Not that we're expanding out again, but I want to make sure that you know that there are two instances of whatever we put here next, okay? So this next thing, this is a difference of two squares here. And you're like, this isn't a square. Yeah, it is. Remember, we're squaring x squared, right? Now that we brought this x back into here, x squared is being squared. I'm not going to use u substitution this time. I already said that. So this factors into x squared minus 1 times x squared plus 1. And remember, there are two of these. So we got to square those and square those, right? There are two of each of those. That's why I said it might be important to expand it out. If I had x to the fourth minus 1 times x to the fourth minus 1, this is x squared minus 1, x squared plus 1, x squared minus 1, x squared plus 1. So there are two of them. And now I have a difference of two squares in x squared minus 1 that I can factor out even further there, which is x minus 1 times x plus 1 right there. And both of those are squared right there. And then there's x squared plus 1, which is squared. So that's the full factorization of that one, guys. Everything squared like that, bringing it out. Like I said, you might have to write out more of those to work it out and see that. Full factorization and then condensing as much as I can as well. All right, number 28 may run into some of the same things being to the fourth power, but that is where we're going to begin. This is sum x to the fourth times x to the fourth right here. Positive product, negative sum means minus minus, and we got to find two numbers that multiply to 9 and add to -10. That's -9, -1. And I can automatically see here, we got difference of two squares, and this will kind of break down a little bit more, right? So this is x squared minus 3 times x squared plus 3. And honestly, those can't go down anymore. No difference of two squares. 3 is not a perfect square. This one is x squared minus 1 times x squared plus 1. And x squared minus 1 is a difference of two squares, so I can keep working that down. And you know, the order I'm writing these parts isn't beautiful with these. Sometimes I like to get some things in particular, bigger numbers first, and then squared parts later. You know what I mean? I'm just going straight down with what's here. X minus 1, x plus 1, and then x squared plus 1. In some form of this, those should be your values, your final result there as we factor completely. Yeah, so we're just having more fun with the factorization of these bigger guys in that regard. It doesn't look like much more is being applied. We aren't doing what it looks like, something where this is a 6 and then pulling that out. So, hey, no, unless they're on the next page. I don't see them. So we'll see if they pop up later. We'll see if they do. I haven't scanned this yet. X squared is a common factor here, and you have x cubed plus 1. And you would be done if this wasn't a sum of two cubes. Now your sum of two cubes formula is a plus b times a squared minus ab plus b squared. Like that. So that second guy there factors into, remember we're cubing x and cubing 1. So it's x plus 1 times square the x, multiply x and 1, and then square the 1. Now this cannot factor more. This cannot factor more. You'll be set on that one right there. Okay. The next guy here. Now, as long as this is a quadratic, there are instances where I think it could break down more if it was larger, and this one seems to be. This is also actually, you can treat this in one of two ways. Check this out. You can either treat this as a difference of two squares, like this, or you can treat this as a difference of two cubes. Now, let's see if we run into the same thing. Well, we'll see how they come in. Difference of two cubes, like this. Kind of interesting, huh? You are cubing one set versus the other. Let's look at the difference of two squares to start here. That's going to leave you with a minus b times a plus b. And check that out. Those are sums of two cubes and difference of two cubes right there. Let's keep going on that. That is x minus 2 times x squared plus 2x, right? We're cubing 2 there, right? Cubing x, cubing 2. So plus 2x plus 2 squared times, and then this is x plus 2 times x squared minus 2x plus 2 squared plus 4. So that would be that final result there. I'll kind of leave that. I gotta fly. That's bugging me. There's the final result right there. We're all good. That's a full factorization. These are a little bit different than some of the ones I've done with my kiddos, but if you recognize them for what they are, you are good to go. Let's try this one here now. Difference of two cubes. This is going to be x squared minus 4 times, and then we have, difference of two cubes, right? X squared plus, and then 4 times x squared, 4x squared, plus 4 squared right there. Now, this is where, so, hold on. This is x minus 2 times x plus 2. Okay, so what you'll notice right here, this is where things do get a little interesting when I talk about it. This is x minus 2 times x plus 2 right there, which we see here. But then this guy seems to have broken down in some other way here into this and this. And what I mentioned was this guy's never factorable. I said as long as it's a quadratic, it's never factorable. But some other things do come to play when you get something like this here. And I'll be honest, sometimes I run into trouble with this because this isn't a normal kind of factorization that you'd see. You gotta see this one differently. I'm not really good at these ones right here to say how it breaks down. I know other teachers are pretty good at that and showing you how you can get a factor by grouping and work it out. I'm actually going to, for the sake of me not getting it wrong, I'm going to go ahead and say if this is what you got and you left it there, with this guy here, x to the 4th plus 4x squared plus 16, I'm not very good at getting those ones broken down personally. But it's got to be some way where you're breaking down to this trinomial times trinomial. You can see where things change, and I can, if I work my magic right, I think I can get it. But I don't want to kind of botch that one right now. It's probably not worth the effort to do so. But this can factor down into this times that, right? This can factor down to this times that somehow. Because if you do distribute that out, that is what you will be getting. So notice difference of two squares actually benefited me more in this case than difference of two cubes. We wanted to get the same answer, but we didn't quite. So this is the full factorization. This one I stopped short. Like I said, if this is a quadratic, this can't factor down more, because given only two solutions, they have to be complex conjugates. When it comes to these ones right here, as they break down, those complex conjugates turn rational suddenly. And these ones are no longer imaginary, so turning rational means possibly factorable. Anyway, there's that. All right, let's keep going here. We are 3/5 done. I don't know how the time's going to go here. So here, I think I'm going to do the same thing. Treat it as a difference of two squares and not difference of two cubes, because my options could be either this or this, given that one is both a perfect square and a perfect cube. I think I'm going to botch this one again if I run into something with to the fourth powers, things like that. So I think I'm going to go with difference of two squares, leave me with a sum or a difference of two cubes and some two cubes that I can work out there. So this becomes, right, this is x cubed minus 1 times x cubed plus 1. It's going to be the same thing as last time here. The difference of two cubes is x minus 1 times x squared plus x plus 1 squared. And then this other guy here is x plus 1 times x squared minus x plus 1 squared, like that. So again, not most fancifully written, but that's the full factorization. These quadratics cannot factor more. Quartics, yeah, it's possible. All right, last one here, I think. There might have been some on the back side, I can't remember. X is a common factor. We're left with x cubed plus 8. Once again, a sum of two cubes there. Did we have this question? X plus 2 times x squared minus 2x plus 4. We probably had something close to it, but GCF of x right there, sum of two cubes. A lot of good practice with all those. A lot different than I'm sometimes even doing with my kiddos there. So good work, good stuff there. All right, we have some other ones to factor here. I do see a GCF of x in both of these. Let's go to work and see what's happening on them. I'll go and write the f of x. We got x times, looks like a factoring by grouping here. X cubed plus, so no rational root theorem just yet. I think we're going to maybe run into these next or pretty soon. Minus x minus 7. So this x will stay on the outside. Check that out. X is going to stay on the outside. We're going to factor by grouping here. Find the GCF of each of those pairs. And inside here, we'll have x squared factored out with x plus 7. That is a 7. And then a negative 1 factored out here to get x plus 7. The x on the outside here is multiplying by everything on the inside here. I got a x plus 7 factored out, and x squared minus 1 factored out there. And x squared minus 1, of course, is x minus 1 times x plus 1. Let me do that again. Is x minus 1 times x plus 1 and x plus 7. Okay. A lot of special case factoring here. You can tell why knowing your difference of two squares thing is pretty important, and some difference of two cubes. So next one right here, another GCF of x, and we have x cubed minus 5x squared plus 7x minus 3. Not factoring by grouping. This is not, if you factor this out, you don't get the same shared thing as this. So this is not factoring by grouping. If rational roots exist, and I can't guarantee it, I have no idea. If rational roots exist, we are doing our rational root theorem here. Other classes might do them differently. I call them my p's and q's. Q's are my factors of 1, and p's are my factors of 3 right here. We are going to test some p over q values, test all possible rational roots. Positive or negative 1 and 3 divided by positive or negative 1, which is plus or minus 1, and plus or minus 3. We're going to test these four values into just here. I don't care about the whole x to the fourth. In fact, I think I don't want to look at that. I just want to look at these ones right here, because this is where x is 0. We're not solving, by the way. We are factoring. I'm trying to see if there's anything else I can factor rationally. So I'm going to test 1 into here. Plugging in 1 is 1 minus 5 plus 7 minus 3. So 1 minus 5 is negative 4, plus 7 is 3, minus 3 is 0. So 1 is a factor. If 1 is a root. 1 is a root. If 1 is a root, then x minus 1 is a factor, right? So right now, as I factor this thing, right now it's going to look like x times x minus 1 times something. And that something will come from dividing this by x minus 1, which means use the 1 root with synthetic division on this right here. 1, negative 5, 7, negative 3. And I should get a 0 remainder this time. Every time I use synthetic division here on out, I'm probably going to be getting 0 remainder because of what's kind of going on this thing here. So there's my 0 remainder. So this factors into x squared minus 4x plus 3, which now, seeing it as a quadratic, I can go, okay, that's factorable. Not all of them are, but this one is. This one factors down to, and I hope you understand the order I'm writing everything there. This factors down into x minus 3 times x minus 1. Negative 3 times negative 1, negative 3 is negative 1. And if I want to write things a little more plainly, x minus 1 times x minus 1 can condense here into x minus 1 quantity squared. So x times x minus 1 quantity squared times x minus 3. That is the full factorization of that guy. So rational root theorem helped get me something after the GCF. I plugged in 1, that seemed to work out, and we're probably going to be using rational root theorem the rest of the way. I didn't expect it here, but there it is. All right, let's keep going. I've got 16 problems to go. Ooh, 35 minutes till my draft. Here we go. Factor each. One root has been given. So they're giving you the root of 3. We don't have to use rational root theorem to figure out that 3 is one of them. I will mention that x is also a greatest common factor right here. So I'm actually going to start with that. It does say factor. It doesn't say solve. I know it says equals 0. We're going to have to ignore that. We're not solving. So I'm going to start by factoring out x. We will have x cubed plus 4x squared minus 9x minus 36. 3 is one of the roots. Apparently 0 is as well. But 3 is now one of the roots given what we have here. So let's go ahead and use that 3 root on synthetic division. If they tell you a root there, that means you must get a remainder of 0. If you don't get a remainder of 0, either the problem's wrong or you did something wrong. And I got a remainder of 0 there. So now this factors into x times x minus 3, that's this root of 3 as a factor of x minus 3, times x squared plus 7x plus 12, and that factors into x plus 3 times x plus 4. So that is x times x minus 3 times x plus 3 times x plus 4. So they gave us a root. We used synthetic division after pulling out a GCF. A GCF was there. And then that's our full factorization of that. If you want the roots, they are 0, 3, negative 3, negative 4. They didn't ask for them. They asked to factor. So factor once again, 2 is the root. No GCF I can see here. I could factor by grouping. I could solve this whole thing factoring by you. Let me factor by grouping and show you what's going on here. I could have factored by grouping. You know what? That can't factor by grouping. This one could have factored by grouping as well, I just noticed. I'm not going to factor by grouping. I'm going to satisfy the thing and tell you which ones you can and then which one you can't. Okay, so right here, 2. Factor by grouping when you can, but synthetic division's the practice now. But no GCF on all 4 terms. So 1 times 2 is 2, and then negative 2 is negative 4, negative 8, negative 16, 0. 0 remainder here. So this factors into x minus 2, and then x squared minus 2x minus 8. We did this before. That's x minus 4 times x minus 2. If it's x minus 4 times x minus 2, then you square the x minus 2 there. Oh, x plus 2. You almost got me. I wanted to square something that's not going to work. It's x minus 4 times x plus 2. We've seen it before. How did I get that wrong? All right, this one I could not factor by grouping here, so I'm going to use that 3 absolutely. Right here on synthetic division. And of course, synthetic is faster on these. I always promote it now. So here we go. Almost like it's a race. Whoops, I meant to write a 20. Here's my 0. I read way ahead. This is x squared plus 9x plus 20. So x plus 5 times x plus 4. So x minus 3 is a factor. X squared plus 9x plus 20 is x plus 5 times x plus 4. Okay. I have some kiddos that tell me to speed up. Other ones say slow down. I'm meeting halfway in the middle. We already did a bunch of factoring, so I'm going faster at the end now. If this is the speed you wanted, you got it. X is a GCF right here. I could have also factored by grouping with this part here. I'm not going to. Negative 2, given, I don't know why they're saying equals 0 here. Negative 2 is one of the roots. I guess calling it a root for the 0. But negative 2 is one of the roots here. And let's go and play with this inner guy right here. 1, 5, negative 4, negative 20. Now I am still pulling out the GCF. And here's the thing. You could use synthetic division on, you could use synthetic division on this right here. You just have to remember that 0 is the last thing that shows up here when you end up doing division on it. So I'd rather pull it out now, have it be a non-factor, and no pun intended, it is a factor, but have it not factor into this right here, and then just go to town on that. Even though I'm not factoring by grouping, I'm getting my GCF because reasons there. So this is x squared plus 3x minus 10, which factors to x plus 5 times x minus 2. So x is a GCF. I got x plus 2 as a factor, and what I say? X plus 5 times x minus 2 are the last ones there. Full factorization of that guy. Okay, this next 4. Write a polynomial function of least degree with integral coefficients that has the given zeros. So here's the thing. They say least degree. That means as small as you possibly can. These are the zeros, which are the roots. That means x equals 1, x equals root 7. So in factored form, that would be x minus 1 and x minus root 7. What they want you to do is write this thing out like this. Now, I'll tell you what here. If I FOILed these things out, if I multiplied all these straight up, that would be what? X squared minus root 7, x root 7 minus x plus root 7. These aren't integral coefficients right here. I have some root 7s in the way. How do I get them to be integral coefficients? If 7 is one of your roots, its conjugate is also a root. Negative root 7, I should say. There's a plus or minus root 7 thing going on here, and that's what we're going to include here. X equals negative root 7, so as a factor, that's x plus root 7. These two together, and this is what I'm going to FOIL first here. And by the way, I don't know, some teachers are going to say just write the factored form and you're good, and by and large, I could look to do that. This could be an answer. But if we want to write it in standard form, fully expanded right here, this will give me a cubic right here, and I'm going to go ahead and multiply these ones out first, mostly because they're a difference of two squares. This is a squared minus b squared. Root 7 squared is just 7. So a squared minus b squared there. And I'm going to multiply that by x minus 1. My OCD is kicking in. I want to write the x squared first, plus I need to get in standard form. So let's now FOIL the rest here. I get x cubed minus x squared minus 7x plus 7. And there is an answer there. It is least degree. Now, what are other answers you could have? You could just multiply these by any integer factor. This could be 2, 2, 14, and 14 like that. I'm not going to do that. I'm going to keep them as they are. But this is kind of one of the answers they're looking for there. Now, these other ones get a little more difficult here because you have more to work with for multiplying out. So unless they're just looking for that answer here, there's a little more to do here. So check this out. Negative 2 plus 3i is one of yours. And like I said before, you need a conjugate to this guy, which is negative 2 minus 3i. The 2 stays negative. That's when you multiply things out that way, you get rational coefficients properly. So these are the three roots we're going to play with here. That makes your factors x plus 3. X, remember, it's opposite of whatever this is. So x minus negative 2 plus 3i and x minus negative 2 minus 3i. There are a bunch of different ways you can go about this. For some people, this works out a little bit better multiplying these things out because, I don't know, reasons. I'm going to go ahead and distribute the negative so you're not dealing with this negative mess. I think that'll just be cleaner for us. Now, again, this could be our answer right there. Probably cleaned up. I think we might need this cleaned up one, so it looks like x plus 2 minus 3i and x plus 2 plus 3i. And you know, this goes back into that form what I was talking about when you have these three terms here and kind of that conjugation where it does clean up. This will become a trinomial. I can't tell you what it is off the top of my head. I'm not good at that. I got to practice it more. Then maybe another video I can do that. But I will multiply those things out for you right here. And I'm going to start with these ones just to show you what it cleans up to be. We're going to multiply x by these, 2 by these, negative 3i by these. All the i's, if done right, will cancel out. I can almost ignore those terms saying they'll cancel out, except multiplying negative 3i times 3i at the end. So this x plus 3 will be multiplying by x squared. You know what? Maybe I'll come up with the pattern here in a second. Plus 2x plus 3ix plus 2x plus 4 plus 6i. That's one that'll also cancel. Minus 3ix minus 6i minus 9i squared. Now, there's a parenthesis that closes there. Sorry about that. Just going to have to ignore that for now. Still a lot more to do here. So cleaning this up here, that gets us, check this out. 3ix minus 3ix goes away. 6i minus 6i goes away. You're left with a 2x plus 2x here. That's 4x. And you're left with a 4 minus 9i squared. I squared is negative 1, so that becomes a plus 9. So plus 4 plus 9, that becomes 13 right there. So I can't say that I know how that cleans up. My guess is, and I'm going to try it for another one. I'm going to try it for one of these later. I guess I'll probably botch it because these are irrationals, not imaginaries. But this became the 4 plus 9, that's squaring 2 and squaring 3. And then this doubles that 2. I'm going to guess that's a part of that right there. And again, maybe I can factor that other thing for you. Maybe I can find out what that was supposed to be going back. But those weren't imaginary values. Maybe I can't. Sorry, here we go. Let's keep distributing here. We get x cubed plus 4x squared plus 13x plus 3x squared plus 12x plus 39. And then that all combines to x cubed. Let me write it out as f of x. Running out of room though, this is f of x equals, and I definitely have to pause my draft at some point, it looks like, x cubed plus 7x squared plus 25x plus 39. So, my choice in expanding this out is I don't know what's going to be expected, but I did expand that out right there, and that seems to be what that thing factors down to. Who knew? I didn't. So there is that. Let's keep going. This one already does show the conjugation. That doesn't help me much because I could come up with that on my own, but we can just make it into a cubic. The factors would be x plus 1, x minus this, so plus 3 minus root 3, and then x plus 3 plus root 3. Like I said, there are probably faster ways to do this. This isn't one I do very often. I'm guessing if I do this right, and I don't know if I will, I'm guessing that this part will turn into x plus 1, let's see if I can get the pattern, into x squared plus 6x plus 6. That's going to be my guess. We'll see how I did. Let's see. And if it is, then I'll go for that pattern for the next one if I do it. Oh, no. If I do it right. All right, so let's see how this one goes. So x plus 1 times, here we go, x squared plus 3x plus x root 3 plus 3x plus 9 plus 3 root 3. Remember, any irrationals are going to go away here. Minus x root 3. It's probably the one part I could save myself on. Minus 3 root 3. Minus 3. That minus 3 comes from negative root 3 times positive root 3. So right here, x root 3 minus x root 3 is gone. 3 root 3 minus 3 root 3 is gone. So see what's left here? Let's see if I did this right. This becomes x squared plus 3x is 6x, plus 9 minus 3 is plus 6. I did do it right. So there is a pattern there that I could work out. I am doubling this value right here, whether it's positive or negative. I doubled that. And then I am doing this squared minus or plus whatever this squared, minus this squared here, whatever it is. The only thing here when I added 9 on this guy was squaring I squared gives you negative 1. That became addition. So I think I can do that. I think I can get that in. And there must be, like I said, an easier way to write out that pattern. But I still got to distribute this guy right here. So that's x cubed plus 6x squared plus 6x plus x squared plus 6x plus 6. I don't know why I left. This becomes f of x equals, here's our polynomial, x cubed plus 7x squared plus 12x plus 6. Yay! All right, I will kind of try that thing on this last one here. We'll see how I do. Whoops, I do not want to move what I was doing here. Here we go. All right, number 42. So let's write out the conjugates here, right? Our roots should be positive and negative 3i, and then 1 plus or minus root 5. So there will be 4 things to deal with. First 2 aren't that bad. I know what that distributes to pretty easily. I wish we had a few more of these. So this is x. For the plus 3i root, that's x minus 3i as a factor. And then for x negative 3i as a root, that's x plus 3i as a factor. And then this guy has x minus, you subtract the 1 and then subtract the root 5. And then here you subtract the 1 and add the root 5 here. And I think I'm going to try and do this one faster. Let's see if I got this. This is x squared minus 9i squared, so x squared plus 9. I know that one pretty fast. That's my difference of 2 squares. Now it's a sum because they were imaginary. Change the sign. This one here, I guess this should be x squared, I think minus 2x. I'm just hoping I do this right. I'll check the answer key in a sec. Minus 2x. And then I don't know if it plus 1 squared plus 5, root 5 squared, so plus 5. Is it plus 6? We'll see when I get my answer here. I hope I'm doing right by you guys by doing this faster. So I'm distributing that. It's x to the 4th minus 2x cubed, because that's me picking up a pattern now. Again, I don't play with these very much, so it's something that I'm sure pre-calc calculus do a whole lot more of this. Haven't done that in a long time. So f of x equals, we'll see if I got this right. I'll pause and check it in a second. X to the 4th, I guess minus 2x cubed plus 15x squared minus 18x plus 54 as full expansion. Is that the right go-to here? And I think it was worth me doing the other thing the first time, because now you kind of learned it here. If I did it right, I didn't do it right. It's not plus 54. Everything else is right, but it's minus 36. Oh no, the 5x squared isn't right. Okay, I didn't do that right. Pause and rewind. Oh goodness. Let's do that again. So I didn't do this part correctly. So I don't know what I did incorrectly though either. I'm not sure. Okay, I'm sorry. See, I tried a pattern. It didn't work out. Okay. Sorry. Let's try it again. So I kind of regret doing it now. So here we go. This is x squared. We'll see what the difference was. X squared minus x. It'll be minus 2x. It's that last term that I guess will be different. Maybe it's a minus instead. I don't really know. Minus x plus, I was probably too assuming on something there. X root 5. Or maybe I didn't multiply something right in distribution. Minus x. I'm kind of dismayed now. I feel kind of plus 1 minus root 5. Minus x root 5 plus root 5 minus 5. Oh, minus 5. See, why didn't I notice that? I did that this time. Why didn't I notice that? I probably had it right. It was 1 minus 5, not 1 plus 5. Oh, I'm wasting so much time on you guys. I'm sorry. X squared plus 9 times x squared. These are gone right here. These are gone right here. I should have noticed that. Minus 2x, 1 minus 5, minus 4. I said plus 6. I did 1 plus 5 instead of 1 minus 5. And I knew that. I knew that because we did that right here. I just thought about the previous problem on it. All right, I'm sorry. All right, x to the 4th minus 2x cubed minus 4x squared. Darn it. Plus 9x squared minus 18x minus 36. Okay, so that combines to... So close. X to the 4th minus 2x cubed minus plus 5x squared minus 18x plus minus 36. And I think that's what it was. Oh. Okay, I think I do know the pattern now, though. And hopefully you guys got it. This squared minus that squared. Duh, it's a difference of 2 squares. Why am I not seeing that? Okay. Let's move forward. Let's have me stop shaming myself now. I only have 8 more problems to do. We do have to find the zeros on those and find the zeros in those. Here we have to find the rational zeros only. Here we have to find all zeros, which means we might have to use quadratic formula, completing the square or whatever. So state the possible rational zeros. That's my p's over q's. Some classes they'll say m over n. So you got to divide all factors of 2 by all factors of 1. That's 1 and 2 plus or minus. So those are all the possible ones. Now, this is not factor by groupingable. None of these seem to be. So we're going to have to use our tests right here to do this. Plug in the numbers until we get 0. So f of 1 will give us 1 plus 9 minus 21 minus 2. That's not going to work. Negative 1 gives us negative 1 plus 9. That's 8 plus 21. That's not going to work. 2 is going to give us 8 plus 36. That's 44 minus 42 minus 2. That's going to work. So 2 works. F of 2 is 0. So that's one of our rational zeros. But as I write this in factored form by dividing the root of 2 out from here, I'm going to get 1, 11, 1, and that's it. So, and this doesn't seem to factor anymore. So this guy will factor into x minus 2 times x squared plus 11x plus 1. Now they asked for the zeros, so let's not do f of x. Let's set it equal to 0. When you set it equal to 0, all the rational zeros, this is the only one right here, x equals 2. If this thing cannot factor, listen, you might not know whether or not it's factorable. You can test it. 2 numbers that multiply to 1 and add to 11, nothing. X equals 2 is the only rational root. These ones will have irrational roots right there, which If this problem was listed down below, we would actually be we'd find all zeros. I'm not going to here. 2 is our only root with a multiplicity of 1. Excuse me. Factors. Possible factors here. Whoops. Your p's over q's in number 44 are plus or minus factors of 21 divided by factors of 2. So that'll give us plus or minus 1, 3, 7, and 21. And plus or minus those divided by 2. So plus or minus 1 half, 3 halves, 7 halves, and 21 halves. My hope is one of the integers will be it, and if they get too large, I'll probably be using my calculator for some of them. I haven't used it yet, but let's try 1 and see how that works. We get 2 plus 2, 4 minus 31 is negative 27 plus 21, no. Negative 1. Negative 2 plus 2 is 0, plus 31 plus 21, no. 3, this is where I might go to the calculator, we'll see. 27 times 2 is 54, plus 18 is 62, minus 93 is negative... Did I say 62? It might be 72. Hold on a second. Let me do that again. 54 plus... Did I say 18? That is 72. Minus 93 is negative 21 plus 21 is 0. So 3 does work. F of 3 is 0. And once I get one of them, then I deal with a quadratic for the rest of it. So synthetic division on 2, negative 31 and 21. So 2, 6, 8. If I got a remainder of 0, then that was right. Negative 7, negative 21, 0. Yep. Oh, good. This factors into this right here. So we can see if that's factorable. I'm going to tell you right now it's not. So this factors into general x minus 3 times 2x squared plus 8x minus 7. And you know, you would play with this right here. You could try and see if it's factorable in some ways. If I would try anything by factoring, I would try out probably minus 1 and plus 7. But that becomes negative 2 plus 7, which is 5, not 8 right there. So that doesn't seem to work out. Nothing's going to work out there. So my only rational root seems to be 3, the one that I found through rational root theorem. Means none of the other ones are there. If you want to know if something's factorable, besides trying everything till it works, use the discriminant b squared minus 4ac from quadratic formula, and if that number's a perfect square, then it's factorable. This thing would be b squared 64 minus 8 times negative 7, which is 56. 64 plus 56 is 120. 120 is not a perfect square, so it's not. All right, number 45. I'll probably do these last two before I kind of pause for the rest here. So possible factors here, your p's over q's in this case are plus or minus 1 and 5 over 1 and 5 here. So your possible factors there are plus or minus 1, 5, and really 1/5, because the other one is 5/5, which is plus or minus 1. So these are our 6 different possibilities right there. I think 1's going to work. You get 5 minus 31 plus 31 minus 5, so that does seem to work there. So f of 1 is all good. When I use synthetic division on that guy right there, I get 5, negative 31, 31 and negative 5 here. So 5, negative 26, 5, and 0. This looks factorable. So this factors into x minus 1 times 5x squared minus 26x plus 5. And I think this factors into 5x minus 1 times x minus 5. That would be negative 25 minus 26. And that should work out there. So you have 3 different rational roots here. You have 1. You have add 1 divided by 5. You get 1/5. And then add 5 here, you get 5. So all 3 are rational in that case there. Okay, in this last one right here, your p's over q's, factors of your constant are plus or minus 1 over factors of your leading coefficient are plus or minus 1 and 3. So plus or minus 1, plus or minus 1/3 are your options here. F of 1, we'll get 3 minus 7 is negative 4, plus 5 is 1, minus 1 is 0. So that does work out. It's good to get the first one out of the way. So using synthetic division now on that guy with 1, we'll get 3, negative 7, 5, and negative 1. Whoops, I wrote the wrong number. I wrote that wrong number. 3. And there. Also looks factorable here. So this factors into x minus 1 and 3x squared minus 4x plus 1. So that guy is 3x. Your only factors of 1 are 1 and 1. This time when they're negative here, that's negative 3 minus 1 is negative 4. So that works out. So and this is x minus 1 twice. So x equals 1 is one of your things here. It says to have a multiplicity of 2. That is a multiplicity of 2. And this, if you add 1 divided by 3, you get x equals 1/3 right there. So, one thing I haven't really mentioned because I haven't really needed to yet, but these last two only had all of our solutions were rational, so I'll just call attention to it. This is a cubic. I expect 3 solutions to it. This is a cubic. I expect 3 solutions. I got x equals 1 twice. It's got a multiplicity of 2. X equals 1, x equals 1, and x equals 1/3. Right? So that's how that's working out. These ones, I only wrote out the rational ones. Even though it's a cubic, there should be 3 solutions. 2 of them are irrational. I did never come up with them. And right here, these 2 were also irrational. So just that one rational solution. On these ones here, I'll mention it more. Fundamental theorem of algebra, find all zeros. These are all cubics, so we'll have at least one rational one. It looks like I could factor by grouping on this one, and this one, and this one. So I will. This one I have to use rational root theorem right here. Let's see how long I can go before you know what, I'm going to go and pause this thing and check out my draft. So I'll be back. Okay, I've decided I'm going to draft in between. I'm going to do problems in between draft picks here. Still 7 minutes for the first pick. All right, here we go. So number 47 right here. State possible rational zeros for each function, then find all zeros. We still got to list the p's over q's. Whether or not we're going to use them all is whatever. So we're going to do plus or minus factors of 85. Wow. We can divide 85 by 1, 5, and that's it. No, I don't know. Let's see. When you divide it by 5, you get 17. So 17 is one of them. I don't know if there's anything beyond those because 17 doesn't have factors, and then 85, I guess, and then over factors of 1 there, which is plus or minus 1, 5, 17, and 85. If I missed one, sorry, I don't know what they are. And calculator, I'm gonna use the calculator for this one right here. I do got to find one of them. This isn't factorable by grouping, so let me show you kind of what that's looking like here. So when I use the calculator on this guy here, I'm gonna plug in that equation and just plug in numbers really quickly into here by going to my table. So x cubed minus 3x squared, I'll type this right, plus 7x, see I didn't type that right, I did that before, plus 7x, I assume I'm writing raised to the second power, minus 85. And I'm going to ask this thing about specific values here. I don't believe 1 works, but I'm going to try 1, negative 1. What did I just do? Negative 1. 5, negative, there's 5. All right, 5 works there, and one of them has to work. In this fundamental theorem of algebra, there will be 3 solutions, and because irrationals and imaginaries come in conjugate pairs, this being an odd degree here means 1 had to be rational, and it looks to be 5. So that doesn't mean it's the only one. The other ones could also be rational. We'll see. Give me 1 second here. Okay, 5 minutes left. So I have the 10th pick, by the way. I can sweat it out and see what other people put here. Okay. 1, negative 3, 7, negative 85. So I got 1, 2. Oh, sorry. Hold on. 10. I thought I was multiplying by 1. 10. 17, 85, and 0. All right, that doesn't look factorable there, so we're going to have to, it looks like imaginary solutions. So we're going to have, this factors into, we got to find the zeros, but this factors into x minus 5 times x squared plus 2x plus 17. Now you set this equal to 0, and like I said, this is not factorable. We got one solution here, though, when x equals 5. The other two come in here, right? In zero product property, either this equals 0 or this equals 0. And if x squared plus 2x plus 17 equals 0, then you can solve either using quadratic formula or completing the square. Now, I'll let you do your quadratic formula thing if you'd like to. I'm going to start with completing the square. I'll do quadratic formula afterward. In completing the square, I need to find a number here that gives me a perfect square trinomial by dividing 2 by 2, which is 1, squaring that is 1, like that. And then I factor this down into its perfect squared quantity, x plus 1 quantity squared. Negative 17 plus 1 is negative 16. I can now take the square root of both sides like that. And here I'll have x plus 1 equals plus or minus, this is 4i. Square root of 16 is 4, and square root of a negative gets you I. Subtract 1, you get x equals negative 1 plus or minus 4i. Those are the other two solutions to that thing. I should probably keep these purple, not blue. So let's change those all to purple. So that's using completing the square there. It's my preferred with that speed when I can use it more efficiently, ideally, and that is when you have a 1x squared and an even linear coefficient. That's good. As far as quadratic formula goes, and I'll keep it another... okay, you probably can't hear that music. It's kind of telling you, it's showtime! Here comes the draft! I'll do it within the green right here, but I'll do it in purple. So right here, my computer's talking to me, sorry. Hopefully I can talk over it. All right, so the discriminant right here would be in quadratic formula 2b squared minus 4ac right there, which is 4 minus 68, which is negative 64. So when I use quadratic formula, we'll go x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times 1, 2a. So that is negative 2 plus or minus 8i, square root of 64 is 8, all over 2. And you can divide negative 2 by 2 to get negative 1, and 8 divided by 2 to get 4. Okay, so those are the three answers right there, whether you use quadratic or completing the square. On this next one, they do say state all possible rational zeros. For the sake of everything here, if you can use factoring by grouping, I'm not going to stop us, but I want to make sure that we do follow the instructions, state all rational zeros, possible rational zeros. So right here, we'll do plus or minus factors of 20 over 1. So 1, 2, 4, 5, 10, and 20. Now we could plug these in until we get one here. I don't want to linger on this too long, so I'm going to go straight into factoring by grouping on this guy right here. So if I factor by grouping, I can be sure to get one of them, and I do know one of them here. So you factor out x squared here, and you get x plus 5. And then here you factor out a negative 4, and you get x plus 5. Looks like x plus 5 comes out of here. And in the other guy here is x squared minus 4. Now listen, if you can factor it, go ahead and do it, right? No one would stop you from making that happen. They did say state the rational zeros. They didn't say find it using rational root theorem and synthetic division. So this also is a difference of two squares, which you could factor, or you could solve using square roots. I'll do the square root portion this time. Otherwise, x minus 2, x plus 2. X equals negative 5 is one of your roots here. That was the one I was talking about. And this is when you set x squared minus 4 to 0. Yeah, quadratic formula is a thing, and yeah, difference of two squares. But you could also add 4 to both sides, take the square root of both sides, and you get plus or minus 2. Remember, there are two answers here, as 1, 2, 3 give you a cubic right there. And don't forget that if you factor this to x minus 2 times x plus 2, you would get the two answers. And also don't forget that it would be plus or minus in the quadratic formula. So I'm getting counted timer. 10 seconds till the draft. So I'm going to go ahead and pause. I'll get my first couple picks, then I'll come back to us. We're almost done. Okay, I've made my first 2 picks there. All right, here we go. Let's go forward. This is, I can factor by grouping here, but before I start, let's get our p's over q's on 49. Factors of 2 over factors of 1. That's 1 and 2. And listen, these are all positive. That really means negative 1 and negative 2 are our only options. I'm actually not going to factor by grouping. Let's go and do this other way. Negative 1 and negative 2 are our only options being all positive. Is it negative 1 or negative 2? We get negative 1 plus 2 minus 1 plus 2. Negative 1's out. Let's try negative 2. Negative 8 plus 8 minus 2 plus 2. That works. So negative 2 works out there. Let's use, I guess I still got to divide. 1, 2, 1, 2. Okay, so this leads me with, and it looks like that was my only rational root. So this leads me with, whoops, I'm going to set it equal to 0. X plus 2 is a factor, and then x squared plus 1 is a factor, right? This is x squared plus 0x plus 1. So x squared plus 1, set it equal to 0. So negative 2 was my only rational root right here, and the other ones come from this. And again, I'm going to solve using square roots there. X squared plus 1 equals 0. Subtract 1. Take the square root of both sides. Now the square root of -1 straight up is I. So this will be plus or minus I. X equals plus or minus I. Those are the other two answers there. So -2, positive I, negative I are yours. And the last one here, again, we could factor by grouping, but if it's plain as day that I can find my thing, I'll not. Maybe I can, if I can do it without a calculator, I'll be good. So my P's over Q's on this final question of the day. We got factors of 10 over factors of 1, so plus or minus 1, 2, 5, and 10. 1 will not work. -1 does not work. 8 minus 8 plus 10 minus 10. 2 does work. So f of 2 is 0 right there. And here we'll get 1, -2, 5, -10. Here we'll get another imaginary set right here. So I'm not really using quadratic formula here. So I'm glad I did use it on that one problem with completing the square to give you one. So this factors into x minus 2 times x squared plus 5. Set equal to 0 right there. And it should be something small like that. It was factorable by grouping. So x either equals 2 as your only rational root right there, or if x squared plus 5 equals 0, then subtract 5, x squared equals -5, take the square root of both sides, x equals plus or minus I root 5. And just in time for the rest of my draft, guys, so we'll see how things are going. All right, guys, that ought to do it for this one. I do apologize for that one problem. I think it was 42. I tried to do a quick step thing, and I could have gotten it. I just added 5 instead of subtracted. Sorry about that one part there. Hopefully everything else panned out the way that it should have. There were also those other ones where this problem here, I think I could probably find a way to go back and see how to do this. I can't trust it fully, so I'm not going to try. But I factored using difference of 2 squares instead of difference of 2 cubes, where I got that broken down there. So that'll do it for this one. I hope that this was very enjoyable for you guys here. Did 50 problems in about 2 minutes a problem. Pretty good. All right. So thank you guys for watching, and take care. I will see you in the next one. And by the way, the next one will involve different polynomial things that we're doing, but probably more in the line of graphs. Take care. See you in the next one.